properties of the definite integral. Okay, we're going to understand these properties. Okay, so definite integral of f of x dx when x varies between a to a equals 0. Why? What is the interval for us? It's from a to a, right? So will we have a region S for us? No. So that means there will not be any region, right, between x equals a to x equals a, right? So there will be no region. So that means the area for this non-region is what? 0. Okay. However, I want you to memorize later. Okay. If we want to compute a definite integral, and we notice that the two limits, one is lower, the other one is upper. If they equals each other, we don't have to compute it. This integral will equals what? 0. Okay, geometrically you understand, right? From a to b, f of x dx give us what? Area of the region, right? So we could even find a region. So area is 0. Okay. Now let's look at this property. This definite integral when x from a to b, okay, I will say a to b, I'll just use ideal case, when y equals f of x, which is totally above the x-axis. So this definite integral geometrically is what? Area of this region, right? This region S. How about this definite integral? It says this equals what? Negative of what? b to a f of x dx. How do we understand the integral from b to a f of x dx? If we assume this b is greater than a, or a is less than b. From this to that, how can we understand why it is negative? So let's go back to our textbook. Okay. Hold on. Yeah, I would suggest you guys, read the textbook. Yes, we proved that, right? Why this is the case? B to A to B. If we interchange these two, okay, interchange these two, it will have, they're going to be what? Offsets, okay? Or let's prove it this way, okay? Let's prove it this way. In order to prove this is true, okay, we're going to add what? This is b to a to b f of x dx equals negative b to a f of x dx, right? We want to prove this is true by how? By adding b to a f of x dx from both sides, because we want this to disappear, okay? b to a f of x. We will have to prove this, okay? So now on right side, see, negative b to a, this is positive b to a, so we have 0. Left hand side, let's see, what do we have? a to b f of x dx plus b to a f of x dx. Well, the sum equals 0. Okay, we'll probably have to learn another property before we can prove this, okay? What is the other property? The other property is this, okay? If we have a definite integral f of x dx and then the limit is from a to b, we could split a to b by what? Between a and b, there is a middle point, what? C, okay? So the integral from a to b can be split by what? The integral from a to c plus what? From c to b. Okay, now here, okay, so a, b, okay, C and C, okay, so when we add up these two, we have a to b. Same thing here, this is from a to b plus b to a, so we can combine that, and we get what? A to a f of x dx. what is a to a f of x dx? It is indeed a 0, okay? So this, I'm just proving that, okay, but here you don't have to memorize that. You just need to know. If we interchange the position of the two limits, okay, we need to have a negative sign, okay, in front of the integral, okay? All right, so this problem is telling us if we have a constant c times by f of x, we can multiply the c in front of the definite integral, okay? And then here, if we have a sum of two functions, or difference of two functions with same limits, okay, limits, okay, or endpoints, okay, or limits, okay, a to b, we could split these two functions by two integrals, okay? It's like a sum of the integral can be, sum of the integral can be written by the integral and then sum, okay? So this is this property. And then say this one, this is important, okay? From a to b f of x dx, if we have a series of some point in the middle of a and b, we can integrate the function f of x from a to c first, and then integrate the function from c to b first. Add up these two integrals will still give us integral from what? A to b, okay? Alright, so these are the properties, okay? Can we move on, everyone? Alright, there are some other properties of the integral, okay? We have the properties 6, 7, and 8. I'm going to ask a volunteer to read these 6 properties for us. Then we can try to look at practice question. Any volunteer to read the 3 properties? Dave?
If f of x is greater than or equal to 0, for a is less than or equal to x is less than or equal to b, then b to a f of x dx is greater than or equal to 0. If f of x is greater than or equal to g of x, for a is less than or equal to x is less than or equal to b, then b to a f of x dx is greater than or equal to b to a g of x dx. If m is less than or equal to f of x is less than or equal to capital M, for a is less than or equal to x is less than or equal to b, then m times b of minus a is less than or equal to b to a f of x dx is less than or equal to m capital M times b minus a.
Very good. Thank you so much. Let's try to understand these 3 properties, comparison properties. This one is, I think this is easy to understand. If a function f of x is always greater than or equal to 0, means what? This function is always above the what? X-axis, right? On this interval from a to b. So the definite integral, which gives us what? Area of this region S. It will always be what? Greater than or equal to 0. That makes sense, right? We just talk about it, okay? If the function is always above the x-axis, okay, then the area of this region is always greater than or equal to 0, okay? Because there's no negative f, okay? F is always positive. And then definite integral will give us what? An area, okay? So the area is, of course, greater than or equal to 0, okay? All right, property 7. If function f is greater than or equals g for axis between a to b. How to understand this? What does f is greater than or equals g mean? Means if we have 2 curves, one for f, one for g, okay? If f is greater than or equals g means what? The curve must be on the top of what? The g, right? A to b. So, what is the definite integral of f? This bigger what? Shaded area, right? What is the definite integral of g? This smaller area, right? So, if f is greater than or equals g, the area must be what? Greater than or equals area from g. Guys, do you see that? Okay, so we'll have this conclusion. Okay, well, this conclusion is f is between m and m. Okay, so y equals f of x, y equals m, y equals smaller lowercase m. So how to understand that? Say for example, when y equals f of x is a curve, okay? What is y equals capital M? When y equals a constant, it gives us what? Horizontal line, say here. What is when y equals lowercase m? See this one, this horizontal line. So our function f is between these two horizontal lines, okay? And then the conclusion will be what? The definite integral of f of x dx, which is what? Everyone, what is the definite integral, the geometric meaning? This shaded area, right? The shaded area, shaded region's area, okay? It must be less than or equals what? M times b minus a. How do I understand m times b minus a? B minus a is what? The width, the length of the interval, right? What is m times by b minus a? What is m? Capital M times b minus a, right? Is area of this bigger what? Rectangle, okay? What is lowercase m times by b minus a? The area of what? This smaller rectangle. Guys, do you see? The area of this shaded region must always less than the area of the bigger rectangle and always greater than what? The area of this one, smaller rectangle. Do you see that geometrically? Okay. Alright, so these are the three comparison properties. We can understand them, and all of them geometrically. Okay? And later we will use them directly, okay, but not in today's class. Okay? Alright, so we have two practice questions. Okay? By using all of the previous properties, remember we learned 5 from the previous page, these 5, and also plus this 3, okay? And I'm going to solve for these two problems, okay? I'm going to ask volunteer to read this example for us. They're not hard questions, okay? I think they're pretty easy questions. Who want to read? Mark, do you want to read this example?
Find integral from 1 to 4 of 3 f of x minus g of x dx if integral from 1 to 4 f of x dx equals 2 and integral 1 to 4 g of x dx equals 10.
Okay, very good, thank you. We want to compute this definite integral from 1 to 4, 3 times f of x minus g of x dx. What we know is, for f of x only, definite integral equals 2. For function g, definite integral is 10. So how can we compute this? How? Can we split this? This is a constant 3 times by f of x, right? So I will split the original function by 3 times by integral 1 to 4 f of x dx minus what? Integral 1 to 4 g of x what? Dx. Can we? Yes, right? From this property. What property? We can split. This one, if we have a constant, we put the constant in front, right? Alright, so what is this definite integral from 1 to 4 f of x dx? What is it? 2. What is the value for this definite integral? 10. So 6 minus 10, -4. Done. Not bad at all. Okay, the last question. Who want to read it? Nick?
There's 3 approaches -2 f of x dx if -2 approaches 1, 5, no, f of x dx equals 2, and 1 approaches 3, f of x d of x equals -6.
Very good. Thank you so much. In this entire question, there's no g. There's only one function f. However, the limits keeps on changing. 3 to negative 2. We want to figure out from 3 to negative 2. The given one is from negative to 2 to 1 and 1 to 3. Think about it. Well, negative 4. Did you add up these two? We do? Okay, let's try, okay? So this plus that give us negative 2 to 1 f of x dx plus 1 to 3 f of x dx, okay? So we add these two, and because this one we consider this is a c, right? This is a to c, c to b. Eventually it will equals what? Negative 2 to 3 f of x dx, right? So this integral give us 2, and then this integral give us what? Negative 6, so add them up. So eventually this integral for negative 2 to 3 f of x equals what? Should equals what? Negative 4. But do you think this is the one we are looking for? Exactly the same? What's the difference between negative 2 to 3 and 3 to negative 2? Oh, so eventually 3 to negative 2 f of x dx equals what? Negative what? Negative 2 to 3 f of x dx. Remember, right? If we interchange the position of the lower limits and the upper limits, we have to put a negative sign, right? So, negative of what? Negative 4 equals what? 4. Answer is 4. Guys, do you see that? So first, yes, we added them, give us negative 2 to 3. We need 3 to negative 2. So negative of negative 4 give us 4.